Yeah, so absolutely. So Terraform, what it lets you do is it lets you package all of your deployments up into a directory. So what it does is instead of going to like the playground where you would just click deploy, you actually create your main.tf, and I'll pull one of those up here. And we'll take a look at one of those. And then within that main.tf file, what you're able to do is actually define all the resources you want to deploy. And when you run that file, what it does is it actually creates those in the same way as it would as if you like were deploying them on the playground. So if like you were just selecting your resources. So let me get some stuff pulled up here and I will show you what I'm talking about. So this is a main.tf file. This is just a actual text file. It's kind of just think of it as a configuration file for your deployment. And what it does is it just sets up all the parameters for you to deploy with. So this is one I've made here. And what you'll see is that you've got in this top section, you've got some variables. And what this does is makes it so that when you deploy, it requests these variables at the beginning of the script, or you can set them in an environment variables file so that you can save them. So for instance, you can have a different file for like mainnet, testnet, devnet, and then you can just specify those by path when you launch the deployment. So then beyond that, down here, this sets where it's telling Terraform that it's going to be using using the grid to deploy its resources. So uh, this actually builds out your deployment itself on the grid. And then this down here sets that the deployment comes out of your wallet. And then what you'll see here is this is what's called a grid network resource. This is what creates ZNets or the zero network. Um, and it's basically a WireGuard-based private network between all of the deployments in this. Um, so this will create a private subnet in the 10.0.0.0 or /16 range. Um, and then below that is where you actually deploy your VMs. So as you can see, like this particular file here has two VMs in it. And I'm able to configure those so that you've got like, I'm able to mount as many disks as I want. I'm able to choose where those disks are mounted, able to set the SSH key for each deployment, and then all of the smaller variables like your memory, CPU, whether it has public IPs, public IP6. Um, and then this last block down here is called your output block. And this is what sets up what returns when you come back through the console. Um, So what you'll see is that like this outputs the config so that you can connect external WireGuard devices into your private network that you created up here. And then you've got the public IP of VM1. So you'll see that basically this outputs the computed IP after the deployment is complete for deployment one. And then the same through down here. So uh, any questions as of yet, or do you want to move on to I can kind of show you how to deploy with it. Okay, so I handle my Terraform deployments in an actual deployment itself. So what I do with them is I have a deployment that I use to just store my Terraform stuff just because I don't have a local Linux machine. Can you see this block that's up? I feel like this may be hiding it. Okay, cool. You can see my console here. No, okay. Um, Hold on. Let me see what I can do about that because it's hiding it because it thinks it's sensitive. see here.
I will try to speak some
There we go.
English.
All right.
Yeah, I can see our terminal. I think it's putty.
Okay. So what this is I've got set up. Um, I just deployed a Ubuntu 2004 in a grid deployment. It's got like 2 cores and 4 gigs of RAM and 15 gigs of space. And this is just kind of where I keep all of my Terraform deployments now, just so I can keep track of everything in one, cohesive space and all that. Um, so basically what I've got set up is we'll go and I'll show you. So we'll just CD to my deployments directory. So this is just something I've created. You can go to deployments, do an ls. And you'll see I've got a couple different things here. You've got gen test and test deployments. These are the different things I've built. So we'll go into gen test here. And then this is going to have, oh, helps if you spell things right. main.tf in here. We'll open that up so you can just see that it's the same kind of thing I was showing you before. So
Okay.
this is just a text file that defines my deployment resources. So we'll see in this particular file, we've got my grid network, and it's going on node 1. And then I've got some deployments here. You've got deployment D1, which is deploying on node 1 with at 1 disk at 25 gigabytes mounted at point data 1. And then you've got the public IP6, and a planetary address. And then it's going to use my variable, my SSH key is going to come either from a variable input at the beginning of the script or from a config file. I use a config file in this setting so that I can do it without showing my keys on, and then you'll see down here, this is going to output the public IP of D1, the public IPv6 of D1, and the planetary IP address of D1. So we'll close that.
Yeah.
So then you'll do terraform init, which you do have to install terraform. I've got some tutorials on that. It's pretty basic, but first you run terraform init, which is going to kind of load in all of your configuration files. And then we'll come up to use terraform apply. And we may get some planetary network timeout errors here, but hopefully we'll get a good solid deployment here. So now it's creating my grid network. So this is just like what you would typically see when you hit deploy on the playground. This is kind of those little delayed windows of it creating the network and then creating the deployments themselves. So you can see it completed the grid network creation, and this is way faster than the playground. That's one of the huge benefits of this.
Can you hear me?
Yeah, I can hear you.
Okay. Where do you define your list?
Your F list. So that's defined just right here. Oh, hold on. I got to switch which screen we're sharing for that. Hold on. Having issues here. So we'll come back over here, and that's just defined right here in the middle of the grid deployment block. So
Okay, you can define a different list for each VM.
Yeah, so you can have, so that's one of the
Yeah.
cool things too, is you can have like, for instance, you could have like a front end server that has a public IP address, but you could run all of your PostgreSQL SQL databases or different types of things like that on a back end server that doesn't even have a public IP address. So
Okay.
what this lets you do is, once you've created this grid network resource here, each one of these VMs is going to have an IP address on this subnet, and then they'll be able to see each other as if they were on a local LAN. So then you can
Okay.
take traffic from, say, like deployment D1, and you can actually forward it on the back end over the private subnet to D2. So you can actually have a web server, like a centralized, like a load balancer, kind of would be the same concept.
Okay.
So it'll reduce your actual need for public IPs when you're hosting like websites and stuff. I know for some of the stuff you work on, it may not be as helpful. because obviously each one of those nodes wants its own public IP address. So,
Yeah.
but this definitely provides the benefit of being able to really configure your deployments a little more, and it can go way deeper than this too. Now, let me switch back over to the console, see what it's doing. Yeah, so you can see we successfully created the two resources here.
Yes.
I take that back. We only created one VM in this one, in this main.tf. But we created the resource, so now we can see that the public IP of our deployed VM is 185.69.161.151 here. So we will copy that. Oh, well, hold on. I don't have the key for that one, but we're in the wrong terminal. Well, I gotta open up PuTTY so I can SSH from my computer because that deployment that doesn't have my keys in it. There we go. So then we are able to just SSH into that deployment as you would any other deployment that you created on the playground.
Okay.
So just like that. So it is. So then what you're able to do is it doesn't just create the deployment. That directory on whatever computer you're running Terraform on now becomes that actual deployment. So it's actually bound to that directory. So say you wanted to get rid of that deployment, you would have to, hold on, let me come back to the other console here, where this is back on my terraformer that I use to store my deployment. So we're still in that gen test directory. So we can come in here, we can do, say we needed to look up what our IP address was for this one, we can do terraform output. Just like that. Or we can come up and we can do terraform destroy. Now you'll see when I'm running terraform apply and terraform destroy, I'm using a variable file.
Yeah.
So what those do is make it so that it saves things like your mnemonics, your SSH key, the value for parallelism, and which network you're deploying on. You can save all of that information into a file on the computer you're deploying from. And then you never have to enter it when you create deployments so that it's completely automated. So you're not having to log in and out, stuff like that. Because it's all local storage, you're able to store that stuff locally. Um, but if you don't run it with that, so let's tear down this deployment real quick. So we're going to do terraform destroy with my var file. That'll add in all my identifying information, and then it will basically delete my deployment.
Okay.
So then I'll show you if you weren't using a variable file, as long as you set up your main.tf kind of the way that I've built this one, when you run terraform apply, it's actually going to ask you right here in the console to enter your words so that you don't even have to have another variable file stored. This is the way that I've built these files. They're actually set up so that if you don't have that variable file, it's just going to ask you for all the information it needs. Obviously, I'm not going to type in my words on here, but
Yes, of course.
now I will show you another really cool thing. And let me stop sharing for a second while I get it pulled up. But I've actually built a
Can
script
you
recently that
can you
lets.
just tell me something? How would those VMs look like on the playground? They
So
would
they just
look like ordinary VMs deployed on the playground?
So they wouldn't show up under like your full VM deployments like you would be used to on the playground. You can go in there and see the contracts, but these exist within Terraform. So it's really something that's more unique to the environment you're running it on.
Okay.
So there is some crossover because like you can go in there and delete a contract per se or something like that, but you're not necessarily able to interact with them the same way you would as one that was created on the playground. I'm gonna get pulled up. I've actually created a script that does a lot of the work, a lot of the heavy work, heavy lifting work of using Terraform for you. I'm gonna get that pulled up. So this is just a basic bash script that I've written that actually generates those configuration files for deployments, as well as your environment variable files for you, so that um, you don't have to do the heavy lifting of that by going in and doing it manually. So you'll see that when you come into here, you've got the install Terraform option that will just install Terraform on an Ubuntu deployment. Then you've got to generate a main.tf and a generate your environment variables.tf So we will do option 2 here and we'll make a main.tf. We'll enter the path where we want to save it. And then it's going to ask us here like what nodes we want to deploy on, and this is for our grid network. So you're going to want to include in this list a total list of all of the nodes that you're going to want to deploy on. So let's say I want to put a VM on node 1 and node 2, then I would use this value here by entering 1, 2. And then it's going to ask you for just a lot of information here that fills in the blocks. So your names, descriptions, and your private IP subnet range. And then if you're adding the WireGuard access, so what this line adds is whether or not you're able to have a configuration so that you can take outside devices that are off the grid and connect them into this private network through just a basic WireGuard client. This will output that information at the end. And then you select the number of VMs you want to create. So in this case, let's go ahead and we'll create 3. And we will put the first one on node 1. And then I've set default variables in basically every line of the script so that you can just thumb through most of these and they will generate a working main.tf. And then on this one, we'll add 2 disks, make them 25 gigs a piece. And then we'll mount those. And then here we can actually choose what we want to output for each individual VM. So it'll ask you how many of these output variables you want to create. So you've got line 1 outputs the WireGuard gateway configuration, and then your public IP4, public IP6, and your planetary network. So on this first one, we'll output all 4. And we'll choose 1, 2, 3, and 4. And then I'm just going to shoot through these. I'll put this on node 2. Now on this one, we don't need the WireGuard configuration because it's the same for every node, so I'll only output 3 output variables here. And we'll do options 2, 3, and 4. And we'll put this guy back on node 1. We're just going to mount 1 disk on these 2. 3 of those. And I think I made a mistake because there's a format up there that I should have been putting in a bracket. I don't think I did, but We'll go back and fix that here in a second. So then we'll just navigate and get it pulled up to our save path. And then you'll see that this actually generated, it has those same variables at the top. It prints, that script prints these variables at the top of every file so that you can either enter this stuff by a prompt or the environment variables file. And then you'll see it created our grid network here on nodes 1 and 2. That needs to be brackets. Need to add that in. But then you'll see it created D1 on node 1, D2 on node 2, and D3 on node 1. And then we'll just go deploy this now if we can. So we are going to go back to deployments. We're going to create a new file for this one.
So you are doing this on
So this,
this is a VM, or you can
yeah,
do it
so
on your computer?
you can do it on your computer too. I keep mine in a VM because I use a Windows machine at home. So it's easier for me to just have an Ubuntu VM that I use for all of my Linux stuff.
Okay.
But yeah, if you're running Linux locally, you can do all of this on your local machine as well.
Okay.
So then we'll just make a directory here and we'll call it tech call. And we'll go into that directory. And then we'll make a main.tf here. And we'll just paste that right on in. Check it over real quick. The script is something that I've only recently written, so that still does sometimes output an error or two. So I gotta check it over. But and then we'll do our terraform init. And basically, if you initialize, it's likely you're probably set up pretty good. Um, and then we'll apply it. I'm going to use my environment variable file. So I think we're likely to run into some timeouts here just from the planetary network, but it might work just on the first try. We will see. If you do get an error that just says IO timeout, it's like, I think it's bad gateway 502. That's just an error of planetary timing out. So it's kind of one of those situations where you just want to try again until it works. Right, it's just being caused by some network latency, but this actually looks like it's gonna work. Oh, well, I guess we are out of public IPs on that farm. So let's go switch that node. So we're going to come back down here. So what that error said is that farm 3, which is the owner of node 2 in grid deployment D2, did not have enough public IP addresses. So we will just change that back to node 1 for demonstration's sake, because I didn't check the Explorer for what was actually available. And then since all of our deployments are now on node 1, we can take node 2 out of our grid network, save that. And we will do another init. And then we'll apply again. Yeah, obviously that's something you want to check when you set up your configuration file and you choose your nodes, just to make sure a public IP is available on the node.
Yeah.
Are you familiar with where to find the direct links to F-lists? So you
No.
can okay, we'll show you that as well. So this is an error that comes up pretty often. It's not an issue with it's not an issue with any node, it's not an issue with any deployment. This is just something that happens on the chain every once in a while. As you can see, we successfully created D2, but D1 didn't create because it had this extrinsic error. It's one of those situations again, you just run it again, and it just seems to be an issue with how the chain stacks input requests.
Do you know what happens to that contract when there's an error deploying?
So this keeps everything in a constantly controlled state. So you're actually managing the same contract when you redeploy it. So if we come up here, you'll see that right here we only added one resource, even though we hit deploy again. That's because it
Mhm.
knows that it only failed to deploy one part of the three resources. So this doesn't create the issue of the rogue contracts like the playground does, where sometimes if things fail, they don't work, the contract doesn't get deleted. This actually keeps constant track of everything from top to bottom, contract deployment itself, all of that.
Yeah, one thing that I think it's missing from the playground is the fact that you cannot do many changes to existing contracts.
Hmm.
Like let's say you want to add an IPv4 to an existing contract. You don't have any chance to change the contract. You have to destroy the virtual machine and create a new one, or just add more disk space or reduce. You don't have any chance to do that.
Yeah,
Um,
so that's definitely something that's a limitation kind of the grid as a whole right now. But my understanding is that you can actually structure your files in Terraform in a way that you can have your disks deployed separately from the deployments themselves so that you can add or remove, so that you can kind of tear down a VM and add a new VM but keep the same disks. And man, the perfect person for this question just showed up.
Hey, what's up?
Hey
hello.
man, we were just talking about doing some deployments in Terraform, and Samau had just asked about functionality to like if you wanted to add a public IP to an existing VM, or if you wanted to add an additional disk to an existing VM.
Yeah, good question. So there's some limited capabilities in terms of how you can modify deployments. And so the kind of the short answer is that it's possible to do quite a bit in terms of making modifications, but it's kind of complicated in how you do it. Essentially, if you have a full VM, you're able to decommission that VM with the disk still in a detached state. So on a full VM, that disk has your root file system and everything within it. So essentially what you do is you pull up a new VM, but it has all the state from your old one. But that new VM can have different amounts of resources. And I haven't tested this, but I would guess that you could also add a public IP as you do this. That's off the top of my head. I was working through because something the community has asked about, like, can we change stuff? And the devs came back and said, well, you can change stuff. It's just kind of not as exactly as you might expect. So it's possible, and I can get all the details about how that works and And you would need to use Terraform to do this. It's not possible in the playground. But as I remember, essentially what you do is you update your deployment, so you keep the disk alive, but you tear down the VM, and you can just comment it out in the Terraform file. And then you run Terraform apply, that'll kill the VM, keep the disk alive, and then you recreate the VM with that same disk as the root mount, but it always uses the first disk. So yeah, new VM with your new specs, in this case public IP, and apply again, and that should bring it back in the updated state.
Yeah. I was just asking if I was doing this question because I was thinking that Terraform could add some functionalities that the playground doesn't have so far. Okay, I was just looking at it as a way to expand functionalities, because when you in some cloud providers, you have a path to upgrade your VMs, but you normally don't have a path to downgrade, and most of the times it's because of the disk. Because if you have a disk and you want to downgrade, probably you will lose some data. So it would be great if you have a VM running and you think you would need more resources, and you wouldn't need to just destroy it and deploy again and back up all things and set all things again. So I was just looking to Terraform as a way to have those functionalities that actually the playground doesn't have.
Yeah, for sure. So that's essentially what you can do. You have to pause your VM for a small time, but you're able to expand the resources that are allocated without needing to refresh all the data. That disk stays alive. I'm not sure if you're able to expand disks, but you can add additional disks to your VM. And if you're using something like BTR FS, ButterFS file system, you could add new disks and then pull them into it's like a RAID 0 array in software. This is something I've done before. That would be a way to be able to expand a disk. That's the only thing I'm not sure if you can do here in Terraform. But in terms of the resources in your VM, you can totally do that. It looks like destroying the old VM and creating the new one, but all the data stays there. It's just the resources allocated that are changed.
Okay.
Just kind of seeing if I could pull off kind of the idea of what I think you explained there. Okay, so let's see what we're doing here. So we still have deployment D1, but we got rid of the disks. So I guess. Okay. So that actually worked swimmingly well. So then we'll come back and so basically what I did there is I took everything below the disks line and commented it out, leaving the last bracket to close the deployment block. and it left those disks active. And then I just had to comment out my output variables down here for the VM so that it didn't call of an output variable that didn't exist. So now if we bring this back, I was showing somehow how I kind of set up my Terraform deployments is I've actually got a VM that I call my Terraformer. Because since I run Windows locally, it works a lot better than trying to do this in Windows. So then I just manage all of my file system and everything for my deployments from that one deployment that I created on the playground.
Yeah, that's a cool idea. I think Zonaris works on kind of a similar concept. I mean, it's automated, but they have a VM that manages all the deployments for their customers, which I
Yeah,
presume is running on the grid.
the way that their stuff works is kind of how I got the inspiration for that script I've been working on. Because I figured if they're batch deploying like that, they must be doing that in some sort of scripted fashion. Because I guarantee there's when they deploy these big swaths of nodes, there's probably not someone sitting there for 2 hours doing it.
For sure. I don't know exactly how it works, but I imagine you could create a Terraform file with variables in it, and then you're able to fill those variables from another file. So in this case, where all the deployments are the same, except for
So
kind of a few
this is
changes.
this is really cool. So yeah, you can still see that the disks blocks are in the unchanged attributes section from the original one. And then it's just re-adding the mounts for those disks. So that actually that's a really awesome actually, because that would allow you to scale even cores or RAM or IP, all of that.
Yeah, for sure. I was super surprised when devs came back. They're like, well, actually, you can do it. You just have to do this. And I was like, well, that seems kind of convoluted, but hey, if it works, then it
Yeah, I
works.
mean, it definitely in the explanation, it sounded, I feel like, a lot more complicated than it was in function. Because yeah, that brought us right back up to having everything here. So that's great. Glad you stopped in. I was showing somehow the latest version of the main.tf generator here a minute ago. It has a root menu now.
Oh, nice.
But I've made it newbie proof. So option one will actually install Terraform with the add the GPG key, do everything like that. It does a pre-check to make sure it's not already installed, and it updates any dependencies that are required. And then option two, when you generate your actual main.tfs now, pretty much everything has default variable and input validation. Oops. So now you can actually successfully create a 2 VM network by doing nothing but, or a single VM, because I forgot to put in two, but you can actually make a working main.tf by doing nothing but inputting the 4 options for your variables. And then let me jump over to the one we just made. And it added it to the other file because it was adding to, not overriding, but yeah. So even with just defaults, now it'll actually generate a working main.tf that you can just immediately deploy.
That's super cool. I
And it
hadn't
takes,
had a chance to test it yet, so it's cool to see it in action.
yeah, the one we just deployed, in the example, we actually generated it with the script, and then dumped it and just copied and pasted it over to my Terraformer deployment and deployed it. And one of the things I really like is you can do this without ever having to enter your seed phrases into my script, because it just prints the variable line here and adds them into the file by variable so that you can actually input them into Terraform directly. So that after you run Terraform apply, it just says, hey, what's your mnemonics?
Cool.
So it's turned out. And then in addition to that, I've added functionality for generating the actual environment.tfrs file as well. And it loops, so it doesn't close when it's done, which took me forever to figure out how to make that happen.
While one.
Yes.
Wow.
It's always the smallest things. Like, I'll have this whole massive function that I just created and had no issues with, and I'll be like, why can't I make this script restart itself?
Of course, in Bash, you have to enclose your one in two sets of parentheses for it to be
I actually just made
properly interpreted.
I made the root menu a bash function, and then I made the script open by calling the root menu function, and I ended the root menu function by calling the root menu function. So
There you go. Yeah.
but yeah, so then you can enter your phrase in, and it'll ask you which network you want to deploy in. You can set your parallelism. Well, wait, yeah. And then you can put your SSH key in. Well, darn input validation won't let me enter empty spaces.
Sorry, what is the parallelism?
That is how many deployments it creates at one time. So like if you have it
Oh,
higher than one, it'll try to create your network and your grid deployments at the same time. And since your deployments depend on your network, you don't want to do that. Correct, Scott?
Yeah, the other issue is that actually I think the main issue is that things with TF chain, what happens is you end up submitting transactions with a higher nonce than the one that's already processed. So you get these errors from TF chain because it's trying to, you're submitting a transaction before the previous one has completed, and every transaction needs to have a nonce that has a
Would that be
one
the
incremented.
error that gives the extrinsic value not high enough?
Yeah.
Okay, well then I have an issue with how this variable works because I don't think it's actually setting that because I've been getting that constantly still.
Interesting. I was curious about the parallelism because I saw this as a variable inside the main.tf, but I don't know how that gets applied because normally it happens on the command line.
Yeah, I may have to rethink how I've done that.
Yeah, I'll take a look at that. It might be, I mean, within your script you can
Oh
just
yeah,
add it to the command. I don't know if there's a way to specify parallelism from inside the main.tf.
yeah,
Check it out.
yeah, I think that one's pretty small though, because you can just add that as you would add your environmental variable line. And I could definitely, one of the more recent things we're working on is making it actually navigate to the path where you created the main.tf and deploy it from within the script. So I could add that in here too, where it saves the path you saved your environment variable file, saves the path you saved the main.tf, and then puts all that together for you. Well, so now, did you have any other questions?
um, uh, you were saying that you were going to talk about the list.
Oh, right. Yeah, I was going to show you where to find a F list to put into that to get the string. So you'll find all of your F lists here on the Grid Hub. So this is kind of like I guess it's just a big repository of F lists that different people have built. These ones up here in gold are the official VMs and stuff. So for instance, for the stuff that you've been doing with full VMs, you would come over here to official VMs, and you'll see the different F list listed. So you'll see like Ubuntu 2004, 2204, and as well as NixOS and some of this stuff. And then what you do, if you want to change the F list on one of those files you generated, you would just hit right click and do copy link address. And then you could either input that into the line in the script as you generate the main.tf, but you could also actually go to the main.tf itself. Is over here. And you would just have to replace this line here. So like this one's on 2004 LTS right now. We could switch that over to 1804 LTS just like that. And then if you wanted to deploy that change, you would just terraform apply it. I imagine that would be a really bad idea to do on something with a file system already in place to try to change the F list on the deployment.
Yeah.
I don't know if it would have any effect.
Yeah, I don't think it would, because it would be just the setup process that I think uses the F list. Because if the disks were to stay mounted, it wouldn't have any way, or stay detached, it wouldn't have any way to modify that.
Yeah, I believe it only applies the F list to a fresh disk.
But yeah, that's where you get the F list, and that's where you put them. The F lists are really cool. You can find some stuff on GitHub about them. I'm not going to try to get super deep into the function of how they work, but you're able to actually take like an Ubuntu cloud image, modify it, and package it so that you can actually have all your files and stuff ready for you when you deploy that F list. I know, like for instance, with your project, the Meson network nodes, you could actually run all of your install stuff and have it all fully installed into your own F list, so that when you deploy it, all you have to do is input your configuration parameters. So you don't actually have to install dependencies and all of that. So you can have a custom image for that.
Wow.
That's something where, like, if we come back to the hub, we can, you'll see down here these lists of different 3bot names. These are, when you upload an F list, it's public, so you'll want to make sure that's not something that ever has like a private key in it or anything like that. Like these always need to just be kind of basic VMs. But like we can come down to my 3bot here, and you'll see that like the cockpit F list are things that I've created that now anyone can deploy, that actually deploy with cockpit already installed in the VM.
How do you create the list? Is it a complicated process?
It is and it isn't. It depends on your level of familiarity with Linux. There is some good documentation on it. If we'll come over to the forums, and I'll show you where to find it. If you look up manipulating cloud images for the grid, this was written by Bert, and this kind of walks you through how to do it. Basically, the steps break down to: you download an Ubuntu cloud image, and you get it running as a VM locally, modify the image, and then you package that VM's file system up in a image.raw that needs to be named image.raw specifically. And then you tar it into a tar.gz and upload that to the hub. So it seems pretty complicated. It's not as once the first time you actually are successful with it, you'll be like, oh my God, this is way simpler than it seemed the entire time. But it does take a little bit to kind of just find all those little steps, especially if you're not super familiar with Linux. But if Linux is your thing, it is a great way to do it. I actually, if you come a little bit further down in the thread, there is a video down here that I've created that is kind of the same concept as what I'm doing with the terraformer, but I'm using a deployment itself running cockpit to actually create an F list. So it walks you through how you could actually just create a deployment on the grid and build an F list in that deployment so that it's not reliant on what systems you're running locally. And it kind of creates a universal tutorial.
Okay. I will take a look at that. I will see that.
Cool. I'll shoot you this link in our Telegram chat.
Okay.
So you can have it.
Thanks.
So this is pretty standard stuff in terms of working with VM images. So there's a few details that are probably grid specific, like Drew mentioned what you name the file, but in general, these steps are just whatever you would need to do to create or manipulate a VM image that would be intended to go into a cloud environment. And because that's the case, you can also take VM images, pre-existing VM images, and with very little work, pack them up and upload them to the hub. I did this with an Ubuntu, just to bring the latest version of Ubuntu that was released, and it didn't require any changes at all. You can just grab that image that came from Ubuntu and we can upload it to the hub. And in the case of another example given by the devs is they did an Arch Linux install where they actually created a fresh VM and then installed Arch Linux into it the same way that you would on a regular computer. So just to say, like, this process is fairly generic, and there's, you know, a lot of good resources out there that are probably applicable up until the last couple steps of what you do here, where you need to properly name the file and put it in the tar archive and upload it to the hub. And for completeness, I'll also mention that so the flist is the unified format that handles both the micro VMs and the full VMs. And this cloud images process that you're seeing here is for full VMs. In the case of micro VMs, it's also kind of standard process of working with Docker containers. So anything that you can do in Docker, you can take that end result and upload that to the hub and it will run as a micro VM. Likewise, if you find a Docker container out there that has the functionality that you're looking for, there's a simple way within the hub to upload and convert that Docker container and it will run as a micro VM with very little effort. So these are, yeah, pretty standard toolings up until the last couple steps. And so the cool thing about the grid is that it's very, very compatible with normal ways of working with this stuff.
Yeah, I think that's super important to recognize. Is I think a lot of people get lost in thinking the grid has a lot of intricacy, but really once you get past those first steps of deploying the workload and your SSH into your VM, everything beyond that, you just have to follow your basic tutorials. And that's true in most areas of the grid.
I want to ask you two things. One is about security. And the two is about the privacy of the F-lists. Do you have to use the F-list? Do you have to upload it to the grid, to the hub? Sorry. Or you can deploy it from a private address, from your private location. Can you upload it from your computer, or it has to go to the hub first?
So you can deploy an F-list from any location, but the node that creates your deployment, it needs to be able to download that file. So your F-list needs to be available over the public internet for that node to be able to come and grab it. So it's not possible in the current architecture to be able to create a completely private F-list or private deployment. As Drew was kind of saying earlier, like what you can do is create, put everything except for your secrets essentially into that deployment, and then add that stuff at the end. or after you deploy. But just based on how the grid works, that node out there, it needs to be able to download the flist from somewhere it can reach on the public internet, and there's no way to have a completely private deployment pipeline.
Yeah.
At least not right now.
As far as I know, there's the hub actually does some converting when you
Sorry,
upload the tar
just a
adjustments
minute,
as
okay?
well.
I will come back in a minute. Sorry.
Thanks for dropping in, Scott.
Yeah, for sure. I'd like
So
to make a habit of it.
I actually have a question for you.
Cool.
Can you work me through a little bit on adding a gateway to a terraform main.tf? Or well, actually, we'll get to that after
Sorry.
he's back. So now where were we at with you?
You were explaining, Scott was explaining about the F list being in a private, being private or public in the hub. I get that. Okay, the other question about security is are these F lists approved, or you can just upload it? How do you upload your F list?
There is not an approval process. So like when you go and upload your F list, it goes on the hub. So that's something where you definitely want to deploy an F list that you are familiar with the creator of. I would not go grabbing random operating systems, deploying them and putting my secrets into them. I would probably stick to, the official stuff as well as, any creators that you're familiar with and trust.
Yeah. Okay.
One more thing to mention here, a distinction between the micro VMs and the full VMs. So with micro VMs, you can input your environment variables into the deployment. So on the playground, there's a tab where you can do this. And within Terraform, there's a way you can add a block for environment variables. But these only get passed to, oh yeah, because you're going to have your SSH key. So in the case of full VMs, the SSH key is the only thing that gets passed through. Any other environment variables are discarded. In the case of a micro VM, you can pass in as many environment variables as you want to. And so this would be a typical kind of pattern would be to anything that is sensitive, you can pass in as an environment variable, and those don't get stored anywhere public. They're not on TF chain. They're sent directly to the node and they're encrypted. So that part, from a security standpoint, that information is safe. We don't have a way to do something like that with a full VM yet. When it comes to full VM, you need to either SSH in manually or use some scripts or something like that to inject any kind of sensitive information into that workload after it's deployed in the case of full VM. Now, I've asked the dev team to activate something that's called Cloud Init, which we're already using to pass in these SSH keys, but this would basically provide a way to insert kind of arbitrary deployment data, environment variables, things of this nature, into full VM deployments as well. But for now, you could use scripts, or there's tools like I think Ansible is one that is designed to, and I think there's ways of kind of using Terraform and Ansible together so that you create your deployment, and then after it's created, there's some setup maybe that you want to perform, and so those are kind of post-deployment automation tools built for doing this kind of thing, where they can install packages for you and set up users or provide environment information and run commands and things like that.
I just pulled up here the, sorry if you guys can hear my servers going nuts behind me. They're going into jet engine mode for some reason. I pulled up the PeerTube example here because it's got an example of a micro VM that's passing some of your data into the VM through the environmental variables block. So this is where it can actually pass in like your web server host name and your port and all of that into the actual VM itself when it deploys. So when you set up the micro VMs, you do get a little bit more configuration ability. But I think what Scott's talking about with Cloud Init, it's going to be really awesome.
Yeah, one day we'll get that. It's on the back burner for now, but it seems like developers are in support of activating that.
Wait 1 second here. Huh. It restarted itself. Anyways, so yeah, Samau, did that kind of answer your questions about Terraform as a whole for today?
Yeah. Yes.
Okay. Scott, I want to just kind of end on a quick question for you. I was looking at this file here and I was looking at how to add the gateway domains, and I want to add this functionality to my script. How exactly does it function to add these blocks for a domain, for a domain gateway?
That's a great question. So there's a couple domain specific examples in Terraform, and I've tested these examples, but I haven't gotten to the point of
Okay,
bringing this into
like
a
a
new
tutorial.
deployment, yeah, on my own. So I don't have a ton of experience working with the gateways, but there's two here: gateway name and gateway FQDN.
FQDN, yeah.
And those are the kind of minimal examples
Okay.
of how you
It's just kind of
can,
where you start.
yeah, set up a gateway. And these are kind of cryptic examples, if I remember correctly. Like
So
something here
the
about,
the idea I got is that you build up here, you build where you want to put your gateway node, and then down here this builds like where to pass the information, and then this builds the domain. But
yeah, so in this case, you have an IP address here that is static. And in the case of a deployment, you're going to want to use some Terraform wizardry essentially to
right,
insert
that one's over
the,
in the other one here. The FQDN has that where it references the well, no, this one's okay. Let's go back to PeerTube because PeerTube had it set up that way.
yeah, the same realization. Actually, PeerTube might be the better place to see this.
Yeah, because it computes the FQDN based off of your variables that are input in the file, and then it passes it to the YGG IP of deployment 1.
So it's working over Yggdrasil. I wonder if there's a way to do this with
So,
WireGuard.
so I'd always been under the impression that the gateways were WireGuard, but I believe if you actually just changed, if you added the output variable VM1 IP1 to output the WireGuard IP, you could just change this to change this line to the VM1 IP1 IP output, it should add that IP instead as the backend.
Yeah, assuming that the gateway is somehow associated with your network, and your network is containing
Because you would
both of
just
these
add your,
nodes.
because you would just have to add the gateway node to your grid network, right? I'm gonna have to play with this.
This is a
I
good question because I don't know if that gateway is going to be able to talk across WireGuard. It seems like it should be. That would be an important feature to have
well,
for performance reasons.
well, and I know when I was reading through the updates on Planetary itself, and they were talking about using gateway nodes as entry points over ZNet for kind of the whole process, and that kind of gives me the idea that kind of what we're talking about here is kind of what they're going to be doing, is using this instead of Planetary for the message bus. So I think it'd be kind of the same concept.
Yeah, that's a good question. I don't know to what extent it will rely on this existing gateway functionality, or to what extent it'll be kind of a new separate thing for R&B. That's a good question. I seem to remember something about this flying by a long time ago, where there was some talk about, do the gateways work over Yggdrasil or do they work over WireGuard?
Yeah,
This
Nelson
is
had brought it up, and I know I had told him that it was WireGuard, and I feel like maybe let's go look at Mattermost, because Mattermost deploys in the same way. I swear I had seen examples of this being done over ZNet. Now this is YGG as well. Okay. Huh. All right, so that's definitely something we can. I'll probably make a forum post about this. That way we can get some input, or maybe open a GitHub issue. One of the two.
for sure. I'll make a note to look into this.
Well, that closes up my questions. Samad, do you have any other questions before we close the call for the day?
No. Uh, I will take a look at Terraform and I'll try to deploy
Yeah,
something with it. Yeah. It's the
it's
best way to learn
well,
is to
yeah, that's how I learn. I call it crashing around,
yeah,
where
yeah.
I just go and beat the console until it finally does what I want it to, and then remember how I did it. Um, but I'll show you if you come over to the forums, I took a lot of and I don't take credit for this because this information came from the information that's in the manual. So somebody had to teach me to do this too. But I did take and kind of reformat that into some other threads here. With how to create the main.tfs in that if you don't want to use my script. I'm also going to be putting my script up for download here soon. I've got a GitHub open on it, but I'm going to make a forum post on it. And these just kind of offer a couple different explanations that rehash the same information in different ways to try to make it a little more understandable for everybody. So there's lots of resources out there for Terraform now, and the manual itself is also a great resource. Sometimes it amazes me because you'll look at the manual one day and there'll be a section that's empty, and you'll look the next day and there's that section plus 5 more, and you'll have no idea it changed.
Yeah.
But it seems there's been a lot of updates coming there. So, but I really appreciate you stopping by, man.
Oh, um, it was a pleasure, and I am the one that must thank you for doing this, not you.
Yeah, thanks so much, Drew, for getting these going. I'm gonna put it on my calendar and try to show up on time on a regular basis from now.
You're
Yeah,
you're you're
I
you're the
just read.
first team member to join one of them, so you're the best one yet.
I was just looking at Telegram and I saw that the call was now, and I dropped by because I didn't remember that it was today at this
Well,
time.
I will take I'll take fault for that because the only reminder that was ever posted about this call was 15 minutes before the call. So
And I saw it, so it worked for me.
I got a little distracted this week. I meant to actually when I make the vid when I post the recording for this one, I actually have to go back and finish the recording for last week's and post that one today too, because it's just been a crazy week with the flu season. But I got some time to catch up. So, but thanks guys, Scott. Thanks for showing up, man. You added some great info.
Sure thing.
Thank you.
Good to
Talk
see
to
you
you
guys.
guys later.
Bye.
Bye.